Hello, ma'am.
Good evening, sir. This is Mahendran. Yeah.
Oh, good evening, sir. Very nice,
Yes.
sir. How are you, sir?
I'm good. How are you?
Good, sir. Good, sir.
Yeah. I will make you a presenter right now. Yeah.
Sir, it's a new chapter I'm starting, so I didn't mention it to madam and the
Okay.
topic. I'll text you, sir, or
Sure. No worry. Yeah. You can text me later. Yeah.
okay.
Thank you.
Okay, sir, okay.
Yes.
So make me a host, sir.
Yes, sir. Yeah. Yes, sir. You are now.
Yes, yes. Right. Good evening.
Good evening, sir.
Yes, yes.
Good evening, sir.
Yeah, good evening, Ajay. New topic. Aldehydes and ketones. Aldehydes, ketones, and carboxylic acid. New topic. Aldehydes, ketones, and carboxylic acid. Aldehydes, ketones, and carboxylic acid. Now, why these are three different classes of compounds? Aldehyde is a different compound, organic compound. Ketones, a different class, and carboxylic acid is a different class. But we study all these three compounds in a chapter together. The reason is, now aldehyde, the general formula of an aldehyde is RCH double bond O. We represent it as RCHO. Likewise, ketones, the general formula is R C double bond O R dash, or we represent it as RCO R dash. Likewise, carboxylic acid, the general formula is R C double bond O OH, or we write it as RCOH. Now, if you observe all these three molecules, in all these three different compounds, we have a similarity. The similarity is all these three compounds contains C double bond O. Since all these compounds contain C double bond O, the reactivities of all these compounds will be almost the same, or the methods of preparation will be on this similar fashion. Therefore, we study aldehydes, ketones, and carboxylic acid under the same topic because they all have CO group. And that CO group is called as C double bond O group is called as carbonyl group. Carbonyl group. Since all these molecules, aldehydes, ketones, and carboxylic acid contain C double bond O, they're also called as carbonyl compounds. Now, what's the importance of this aldehydes and ketones? Now, this aldehydes and ketones are responsible for odor. So it is not only responsible for odor, aldehydes and ketones are responsible for odor, that is smell, flavor, and also taste. So aldehydes and ketones are responsible for odor, flavor, and taste of food. All right. Now, for an example, if you take almond, in almond, we have benzaldehyde. Benzaldehyde is present in almond. If you take cinnamon, we all know this. Cinnamon all is used in kitchen. So cinnamaldehyde, we have cinnamaldehyde. We will learn the structures of these molecules a little later. So most of the food contains aldehydes and ketones, which are responsible for odor, flavor, and taste. Some of the examples I gave you. Likewise, now jasmine, flower, you would have heard jasmine, camphor, you know, we use it at home, camphor, All this also contains a different odor. It has a specific odor. Those specific odor or smell is because of the aldehydes and ketones present in jasmine and camphor. Now, butter, we eat butter. This butter contains butadiene. It contains two ketone groups, dione, C double bond, two C double bond O. Therefore, they are called as what? Diones. So butter also contains butane, dione, ketones, carbonyl compounds, they are present. All right. And some of the hormones of steroids family, such as cortisone, protein metabolism, inflammation reducer, testosterone, male sex hormone, progesterone, female sex hormone, these all contains carbonyl groups. So even the hormones in the body, they all contains carbonyl group. So therefore, this carbonyl groups, this class of organic compounds, that is aldehydes, ketones, and carbonyl group, it's important to study. Not only for commercial purposes, but also for understanding the food, what we eat, and the smell. All the perfumes contains aldehydes and ketones. All right. Now, these aldehydes, ketones are sometimes not good for our system. Now, the whiteboard marker will have a pleasant odor when we write, but that also contains aldehydes and ketones. So constant inhaling, that causes harmless sickness to the body. All right. So, and similarly, in chemical industries, formaldehyde, acetone, they are produced in large scale as a solvent. So formaldehyde in industries, formaldehyde. We will learn the IUPAC name, all that. Formaldehyde, acetone, they are all used as solvent. So acetone is the component which we use, a nail polish remover. When we talk about nail polish remover, that contains acetone. So that gives a very nice odor, but it's not good on inhaling for a long time, right? And these are also used in the preparation of adhesives. It is used in the preparation of plastics. It is used in the preparation of resins. It is also used in the preparation of explosives. So these are the some of the functions of aldehydes and ketones. It gives odor, it gives smell. With the smell, it gives what? Taste, it gives flavor. It is used as the flavoring agents or odor giving agents in jasmine, camphor. All right. Butter contains butane, dione. So hormones contains carbonyl groups, and also it is used as majorly solvents in industries with formaldehyde and acetone. Now, coming to the general understanding or general introduction to aldehyde, we will learn the preparation of aldehydes, ketones a little later. Now, we will try to understand the ketones and aldehydes for naming and the general representation, all that. And then we will go for ketones, and then we will learn the preparation. Now, aldehydes are organic. How do you define an aldehyde? Aldehydes are defined as organic compounds having CHO as a functional group. Any molecule which contains CHO as a functional group is called as aldehyde. So the general formula of an aldehyde is RCHO. This RCHO, the structure of RCHO is RCH double bond O. Carbon should have tetravalent valency. Therefore, the bond between carbon and oxygen will get double bond. Carbon and hydrogen is a single bond. Carbon and R group is a single bond. What is this R here? This R can be hydrogen, or it can be an alkyl group. You know what's an alkyl group? Or it also can be an aryl group. Aryl group means benzene ring containing groups. So this is the general introduction with respect to aldehyde. Definition of an aldehyde, general formula of an aldehyde, and what is R, and all that's the representation. Now, some of the examples for aldehydes. Now, some of the examples, the first aldehyde we will learn, example for aldehyde, we will really replace this R by hydrogen. When we replace this R by hydrogen, we get HCHO. We get HCHO. This HCHO is commonly called as formaldehyde. It is commonly called as formaldehyde. The IUPAC name for this molecule. They can ask you IUPAC name for 1 mark. Now, what's the IUPAC name for this molecule? It contains only one carbon atom. Since it contains only one carbon, the root word is meth. Carbon to carbon, there is no other carbon here. Therefore, we assume the molecule to be saturated. Therefore, we have to write the parent molecule as methane. But it contains an aldehyde group. Since it contains an aldehyde group, this E is replaced by Al. So it's called as methanol, NaL. So this is the IUPAC name of formaldehyde. The second molecule we will take, it is CH3CHO. R is replaced by CH3 group. When R is replaced by CH3 group, it is commonly called as acetaldehyde. Now, what with IUPAC name for this molecule? The longest chain, we have 2 carbon atoms. Since we have 2 carbon atoms, root word is eth. Carbon to carbon single bond. Therefore, the molecule has to end with ANE, ethane. But it contains an aldehyde group. Therefore, this E has to be replaced by Al. Name of this molecule is ethanol. Likewise, now if you take an aromatic compound, if you replace R by CHO, the R group is replaced by C6H5 or a benzene ring. So then the common name for this molecule is benzaldehyde. The common name for this molecule is benzaldehyde. So the IUPAC name for this simple aromatic aldehyde is also called as benzaldehyde, or it is also called as benzene carbaldehyde, CARBALDEHYDE. So the simplest aromatic aldehyde is benzaldehyde. It has the IUPAC name benzaldehyde, or it also can be called as benzene carbaldehyde. Right? These are the simple organic molecules of aldehydes. There are so many millions of organic molecule aldehydes, but we have to start with the learning preparation of aldehydes and aldehydes. Now, similarly, ketones. Now, when we talk about ketones, these ketones are organic compounds having C double bond O as functional group. So any organic molecules having C double bond O as a functional group is called as ketones. The general formula of ketone is R C double bond O R dash. The general formula of the ketone is R C double bond O R dash. Now here R cannot be hydrogen. Only in case of aldehydes R can be hydrogen. But in case of ketone, R cannot be hydrogen. When we say R cannot be hydrogen, it can be only alkyl group or it can be aryl groups. Now, if R is same as R dash, it is called as simple ketone. It is called as simple ketone. And if R is not same as R dash, then it is called as mixed ketone. It's called as mixed ketone. Now, example for ketones. A simple ketone is CH3 C double bond O CH3. The common name for this molecule is acetone. The common name for this molecule is acetone. What is the IUPAC name for this molecule? The IUPAC name for this molecule will be, we have 3 chains in the carbon atom. Therefore, the root word is prop. Carbon to carbon single bond, therefore it is propane. But it also contains a ketone group. Since it contains a ketone group, this E is replaced by ONE. Therefore, it is called as propanone. It is called as propanone. So ketones are named as ONE. Aldehydes are named as NAL, AL in the last. So propanones are named as ONE. Similarly, if you take one more ketone, CH3, CH2, C double bond O, and CH3, this is called as ethyl methyl ketone. The common name for this molecule is, this is ethyl group, this is methyl group, and this is ketone. So therefore, it will be called as ethyl methyl ketone. The IUPAC name for this molecule will be 1, 2, 3, 4. 4 carbon atoms. Therefore, the root word is but. Carbon to carbon single bond, butane. And since that E is replaced by ONE, therefore it's called as butanone. It's called as butanone. So aldehydes and ketones, we will study together the preparation part of it, and then we will go for carboxylic acid. Now, I hope that you understood the definition of aldehydes, ketones, as well as you understood the general representation of aldehydes and ketones. They can ask you an example for or the general formula of aldehydes and ketones. Now, just observe here. In case of ketone, acetone is an example for simple ketone because the R and R dash groups are same. But here, this butanone is an example for mixed ketone because here it's ethyl group R and R dash is methyl group. So R and R dash is not same here. Therefore, butanone will be an example for a mixed ketone. Follow this? Follow with this?
Yes, sir.
Yeah. Now, carbonyl compounds are of two types, basically aldehydes and ketones. Both have carbon-oxygen double bond. I was teaching you this. Both has carbon-oxygen double bond. And they're often called as carbonyl groups. Now, organic compound having C double bond O group are called as carbonyl compounds. And these groups is known as carbonyl or also called as oxo groups. So C double bond O is also called as oxo groups. The general formula of an aldehyde ketone is CnH2nO. CnH2nO. Now, alkanes, we know that the general formula is CnH2n plus 2. Now, these two hydrogen atom is replaced by an oxygen. So that will be the general formula of an aldehyde or a ketone, CnH2nO, where N stands for number of carbon atom. All right, number of carbon atom. Now, structure. Carbonyl compound, carbon atom is joined to 3 atoms by sigma bond. Since these bonds utilize sp2 hybridized orbital, they lie in the same plane and are 120 degrees apart. The carbon-oxygen double bond is different than carbon-carbon double bond. Since oxygen is more electronegative, the electrons of the bond are attracted towards oxygen. Consequently, oxygen attains a partial negative charge and carbon attains partial positive charge, making bond polar. The high value of dipole moment is around 2.3 to 2.8 dBi. And you cannot explain only on the basis of inductive effect, and thus it is proposed that carbonyl group is resonance hybrid of the following isomers. We will learn the following isomers later. Now, what is this trace? Now, if we represent a carbonyl group like this, you can see carbon has 2 bonds with R or H or anything, and it has a double bond with carbon oxygen. What they say is the hybridization of carbon is sp2. You know what is hybridization? Hybridization, mixing of atomic orbitals. So 1 s orbital of carbon, 2 p orbitals of carbon will overlap to form 3 sp2 hybrid orbital. So carbon in carbonyl groups are sp2 hybridized. And you can see clearly they mentioned they all lie in the same plane and 120 degree apart. That means the bond angle is what? 120. So all are in the same plane. So the bond angle is what? 120. Now, oxygen is the second electronegative element in the periodic table. Since oxygen is the electronegative element in the periodic table, what happens is the pi bond breaks, the pi electrons are formed, those electrons will be pulled towards oxygen. When those pi electrons move towards oxygen, oxygen gains partial negative charge and carbon gains partial positive charge. So therefore, these carbonyl groups are polar in nature. Polar in nature. Polarity means molecules possessing positive character and negative character is called as a polar. So carbonyl compounds, aldehydes and ketones have polar character, polar nature because of the highly electronegative oxygen atom. And the dipole moment is defined as charge into distance. Charge into distance. Whether we take a positive charge or negative charge, any of the charge can be taken, and the distance between carbon and oxygen, that's called as dipole moment. The dipole moment is between 2.3 to 2.8 dpi. Now, preparation of carbonyl compounds. How can we prepare carbonyl compounds? Now, carbonyl compounds can be prepared by from alcohols by oxidation. The first method of preparing carbonyl compounds, whether it's aldehydes or ketones, we can prepare from alcohols. Now, how we can prepare aldehydes or ketones from alcohol? And that is by oxidation. By oxidation. So alcohols on oxidation, we get an aldehyde. Or alcohol on oxidation, we can get a ketone. Now, you should understand that. Now, the first one I will write here. We'll try to understand this reaction. This is RCH2OH. Maybe I'll write it in other manner. What's happening? I will write like this: RCH, H, and OH. Now you should tell me what type of alcohol is this? Is it a primary alcohol or a secondary alcohol? Is it a primary alcohol or a secondary alcohol? What carbon atom is this? Is it a primary carbon or a secondary carbon? Are you people there?
Yes, sir.
Yeah, what carbon atom is this? This is
Sir,
R.
primary alcohol.
It is a primary alcohol. This is primary carbon atom because this carbon is bonded to only one more carbon. Therefore, this is primary carbon atom, and this primary carbon atom contains OH group. Therefore, this is the general representation of primary alcohol. Primary alcohol are represented as 1 degree alcohol. This primary alcohol, when we heat it with a mild oxidizing agent or a strong oxidizing agent like acidified potassium dichromate. What do you mean by acidified potassium dichromate? Potassium dichromate in dilute sulfuric acid is called as an oxidizing agent, acidified potassium dichromate. It is a very good oxidizing agent. It is a strong oxidizing agent. Now, what happens is this potassium dichromate reacts with dilute sulfuric acid to give nascent oxygen. What do you mean by nascent oxygen? Oxygen in atomic state will be called as nascent oxygen. So these two will react, potassium dichromate and sulfuric acid, and give nascent oxygen. Now what happens is, listen to this carefully, the hydrogen atom of the OH group and one of the hydrogen atom of the carbon containing OH group. See, these all are carbon atoms. It can be many number of carbon atoms. We don't know. But this is the only carbon which contains OH group. So the H of the OH group, the hydrogen atom of the OH group, and one of the hydrogen atom of the carbon containing OH group gets eliminated along with this oxygen as water. It gets eliminated along with this oxygen as water. When they get eliminated along with this oxygen as water, what is left out? You have R, you have CH, you have single bond O. Now this cannot exist because carbon has only 3 bonds. Therefore, what happens is, since hydrogen from this carbon and hydrogen from this oxygen is eliminated, a double bond will be formed between carbon and oxygen. Since a double bond is formed, this is nothing but aldehyde group, and the compound which is formed is called as aldehyde. The compound which is formed is called as aldehyde. So you should remember, primary alcohols on oxidation, primary alcohols on oxidation gives aldehydes. Primary alcohols on oxidation gives aldehydes. Now, if you take an example, instead of this R, we will take CH3. When we take CH3, the name of this alcohol will be ethanol. Ethanol. So this alcohol, ethanol, when you heat it with acidified potassium dichromate, what happens? This will give nascent oxygen. What will happen now? The hydrogen atom of the OH group and one of the hydrogen atom of the carbon containing OH group gets eliminated as water. So what else is there? Now we have a CH3 group, we have CH group, and you have H group, and you have O. Since hydrogen is eliminated, what happens? A double bond will be formed, and this molecule is commonly called as acetaldehyde. So you should remember, primary alcohols in oxidation gives aldehydes. So oxidation in organic chemistry is addition. How do you define oxidation in organic chemistry? Oxidation is defined as addition of oxygen, or if you remove hydrogen, it's still called as oxidation. So in these molecules, you can see hydrogen atoms are removed. Therefore, it is called as oxidation. So loss or removal of hydrogen will be called as oxidation. Now, coming to the next part of the topic, the same topic, we will learn the preparation of ketones. Now, if we can represent here RC, RC? Maybe I'll represent OH like this, and R. So RCH, and or maybe otherwise I'll represent it like this. You should tell me what type of alcohol is this. RCH, OH, and R dash R. What type of alcohol is this? Now, this carbon is a secondary carbon because this is bonded to two carbon atoms. So therefore, it's a secondary carbon atom. Secondary carbon atom contains OH group. Therefore, it is called as secondary alcohol. The secondary alcohol, when you heat it in the presence of acidified potassium dichromate, the oxidizing agent is acidified potassium dichromate only. So what happens? These two will react to give what? Nascent oxygen. Now what happens? Now the same reaction, the same statement. The hydrogen atom of the OH group and the only hydrogen atom of the carbon containing OH group reacts with oxygen to form water. What else is left out? We have R, C single bond O, and we have R. So what happens? This carbon is not stable. Therefore, there will be a double bond formed between carbon and oxygen. So when double bond is formed between carbon and oxygen, it is called as ketones. The product formed is ketones. Now we will take a simple example, and then I'll write the example here. Now we will take a simple example like CH3, CHOH, and CH3. It is called as 2-propanol or isopropanol. It's called as 2-propanol or isopropanol. Iso means the OH group is in the middle carbon atom. So when this isopropanol is heated with acidified potassium dichromate, this gives you nascent oxygen. So what happens now? This OH, H and OH, and this H reacts with oxygen to form water, and you have CH3, C double bond O, and CH2. This is nothing but acetone. It's nothing but acetone. Did you follow this?
Yes, sir.
Yeah. Now, you should remember secondary alcohols on oxidation. Secondary alcohols on oxidation gives ketones. So the reaction is same. You see, if you take primary alcohols, we get aldehydes. And if you take secondary alcohols, we get ketones. So I've given you the example, general reaction I've given you, and also we have given some specific example. Now here are some of the examples for mild oxidizing agents. So mild oxidizing agent, chlorine is a mild oxidizing agent. Bromine is a mild oxidizing agent. Halogens are generally mild oxidizing agent. Fenton reagent, a mixture of ferrous sulfate and hydrogen peroxide, is called as Fenton's reagent. It's for your information. Nobody will ask any questions based on this, but these you can remember. Now, acidified potassium dichromate, this you should remember. Acidified potassium dichromate in dilute sulfuric acid, or maybe potassium dichromate in dilute sulfuric acid, is an oxidizing agent. Jones reagent, Saret's reagent, manganese dioxide, aluminum tertiary butoxide. This reagent, you will be using it in this chapter, aluminum tertiary butoxide as an oxidizing agent. We will be learning sometime later, remember. So these are the examples for oxidizing agents. See here, when the secondary alcohol can be oxidized to ketones by aluminum tertiary butoxide, the reaction is known as open-R oxidation. So we were learning secondary alcohol on oxidation with dilute sulfuric acid gives ketones. Not dilute, acidified potassium dichromate. Sorry, acidified potassium dichromate gives ketones. But the same reaction, if we use aluminum tertiary butoxide, then this reaction will be called as open-R oxidation. The same reaction will proceed, but the oxidizing agent is different. So that will be called as open-R oxidation. Unsaturated alcohols also can be oxidized to unsaturated ketones without affecting the double bond by this reagent. That's the advantage of this. Unsaturated alcohol. Now, for an example, if you take unsaturated alcohol like this, CH, CH, C, OH, H, and CH3. Now, this when we oxidize using aluminum tertiary butoxide, what happens? These two hydrogen atoms gets eliminated as water. And what else is left out? You have CH3, CH, double bond CH, you have C double bond O, and this is CH3. It is a ketone, but it is an unsaturated ketone. So we have a double bond. So that's the advantage. Without disturbing the double bond, we can prepare a ketone using aluminum tertiary butoxide. And the name of this reaction is open-R oxidation. Now, coming to the next part of the topic. They yield aldehydes, the yield of aldehydes, the amount of aldehydes is usually low by these methods. So by open-R oxidation, the quantity of aldehyde formed is usually low. The allylic alcohols can be converted to aldehyde by treating with oxidizing agent like pyridinium chlorochromate. This is pyridinium chlorochromate is abbreviated as PCC. We will be using this oxidizing agent also later. The molecular structure looks complex. That is C5, C5H5, NH plus, CrO3, Cl minus. This is the formula of pyridinium chlorochromate. This pyridinium chlorochromate is also an oxidizing agent, which is called as tertiary butoxide. The reagent, the reaction is also use pyridinium chlorochromate, PCC, which is called as Collins reagent. This reagent is used in non-aqueous solvents like methylene chloride, dichloride or dichloromethane. It is prepared by mixing pyridine, chromium oxide and HCl in dichloromethane. So this detail is not required. So you should remember pyridine chlorochromate is used as an oxidizing agent in non-aqueous solvent. When we say non-aqueous solvent, where we are not using water as a solvent. So we can use other organic solvents like dichloromethane. So whenever we are using other solvents than water, we can use PCC as an oxidizing agent. Now, the second method of preparation. See, first method is by preparation from alcohol by oxidation. The second method is again from alcohol only. Again from alcohol only. The name of the reaction is called as dehydrogenation. Dehydrogenation. What is this dehydrogenation? Dehydrogenation means the removal of hydrogen as a gas. Removal of hydrogen as a gas is called as dehydrogenation. Now, this dehydrogenation takes place in the presence of copper, in the presence of silver, in the presence of platinum at 300 degrees Celsius. At 300 degrees Celsius. Most of the time, copper is used because copper is cheap and abundantly available. So copper is used. Now, dehydrogenation, as I told you, it is defined as removal of hydrogen as a gas, H2, is called as dehydrogenation. Now, the primary alcohol will represent like this: R, C, H, H, and OH. When vapors of primary alcohol is passed over copper at 300 degrees Celsius are converted to Kelvin scale, 573 Kelvin. You can write it as otherwise 573 Kelvin. I told you, when vapors of primary alcohol, vapors of what alcohol? Primary alcohol are passed over copper metal at 300 degrees Celsius. What happens? What happens? The hydrogen atom of the OH and one of the hydrogen atom of carbon, they get eliminated as hydrogen gas. When they get eliminated as hydrogen gas, then what else is formed? You have R, you have CH, and you have a single bond oxygen. This molecule cannot exist. Therefore, a double bond will be formed between carbon and oxygen. So this will be called as an aldehyde. This will be the general formula of an aldehyde. So primary alcohol vapors, when we pass over heated copper at 300 degrees Celsius or 573 Kelvin, dehydrogenation takes place. Removal of hydrogen takes place, forming an aldehyde. Removal of hydrogen takes place, forming aldehyde. Now, if we take a specific example, we take CH3, CH. This is ethanol. When this ethanol vapors are passed over copper at 300 degrees Celsius, what happens? Now, as we were learning, the hydrogen atom of the OH group and one of the hydrogen atom of the carbon containing OH group gets eliminated as hydrogen gas, and you have CH3, CH, and double bond O. This is called as acetaldehyde. So primary alcohol on dehydrogenation gives aldehydes. Now, what will happen to secondary alcohol? Now, if you take secondary alcohol, what's the product formed? Same statements. Let us see. If you take secondary alcohol vapors, if you pass vapors of secondary alcohol, see this secondary alcohol, because this carbon is bonded to other carbon, 2-propanol, isopropanol. All right, it is an example for secondary alcohol. When the secondary alcohol vapors are passed over heated copper at 300 degrees Celsius, what happens? What happens? Now, this hydrogen and this hydrogen gets eliminated as hydrogen gas. What else is left out? You have CH3, C, single bond O, and single bond CH3. So actually what forms is a double bond between carbon and oxygen. This is nothing but a ketone. A ketone is formed. So many number of examples can be given for the dehydrogenation, but you should know a simple examples like this. So primary alcohol on dehydrogenation, it gives aldehydes. Secondary alcohol on dehydrogenation gives a ketone. All right. Understood these two reactions? Different types of reactions, what we're learning?
Yes, sir.
Now, we will learn with the other method of preparation of aldehydes and ketones. I need some space, so I'll erase this. One minute. The next method of preparation is from acid chlorides. Acid chlorides. How do we get acid chlorides? Now, acid, the carboxylic acid, the general formula of carboxylic acid is RCOH. The general formula of carboxylic acid is RCOH. RCOH. If this OH is replaced by chlorine, then you get RCOCl. So this is a general representation of acid chlorides. Now, for an example, if you take acetic acid, from this acetic acid, if this OH is replaced by Cl, we get CH3COCl. It is called as acetyl chloride. It's called as acetyl chloride. Acetyl chloride is an example for acid chloride. Similarly, if you take benzoic acid is C6H5COOH. If this OH is replaced by chlorine, you get C6H5COCl. This is called as benzoyl chloride, BNZOYL, benzoyl chloride. So benzoyl chloride and acetyl chloride are examples for acid chlorides. So now the third method is from acid chloride. We are learning to prepare aldehydes and ketones from acid chlorides. From acid chlorides. From acid, third method is from acid chlorides. We learned what is an acid chloride. Now, this reaction is named as Rosenmund's reaction, ROSCNMUNDS, Rosenmund's reaction. So all the name reactions, what we are learning in this chapter is important. Now, what is this Rosenmund's reaction? When acid chloride vapors, and hydrogen are heated in the presence of Lindlar's catalyst, LINDLAR, Lindlar's catalyst. What is Lindlar's catalyst? Palladium coated over barium sulfate, or palladium supported by barium sulfate is called as Lindlar's catalyst. Corresponding aldehydes are formed. Excuse me. Now, from acid chlorides, and the reaction name is called as Rosenmund's reaction. What is this Rosenmund's reaction? When vapors of acid chloride and hydrogen are heated in the presence of the Lindlar's catalyst, the corresponding aldehydes is formed. The temperature is normally they use 410 Kelvin. They heat it up to 410 Kelvin. Now, for an example, we will learn two reactions. The first one is from acetyl chloride. from acetyl chloride. So acetyl chloride is a CH3, C double bond O, Cl. This acetyl chloride, when you heat it with hydrogen in the presence of palladium palladium coated over barium sulfate. Palladium coated over barium sulfate. So what happens? What happens? We will try to understand. Now, this hydrogen molecule, we will write it as H and H. So what happens? One of the hydrogen and one of the Cl gets eliminated as HCl. In place of the Cl, the other hydrogen atom goes. So what's the product you get? We get CH3, C double bond O, and you have what? Hydrogen. So this is nothing but acetaldehyde. Nothing but acetaldehyde. So this reaction is called as Rosenmund's reaction. What is the catalyst used in Rosenmund's reaction? They can ask you. The catalyst used in the Rosenmund's reaction is palladium coated over barium sulfate. Similarly, if we use benzoyl chloride, the formula of benzoyl chloride is C6H5COCl. So we can represent that in the form of a structure, C6H5, C double bond O, and C. This, when you heat it with hydrogen vapors at 410 Kelvin in the presence of palladium coated over barium sulfate catalyst. So what is possible? The possibility is this hydrogen and this Cl can get eliminated as HCl as a byproduct, vapors, it goes away. In place of Cl, we get hydrogen. Therefore, the product what we get is C6H5, C double bond O, and you have H. This is called as benzaldehyde. It's called as benzaldehyde. So this reaction is called as Rosenmund's reaction. What is Rosenmund's reaction? Rosenmund's reaction is a reaction between acid chlorides and hydrogen at 410 Kelvin in the presence of palladium supported over barium sulfate as a catalyst. Important reactions. Are you following? Are you following?
Yes, sir.
Yeah. Now, two or three more methods we'll see, and we'll stop for today. This next reaction is from nitriles. From nitriles. What are nitriles? What are nitriles? What are nitriles?
Sir, NO2.
No, NO2 is called as nitrites. Nitrile, Nitrile. Cyanides are otherwise called as nitriles. Cyanides. So the next method is from nitriles. So cyanides or nitriles on reduction. Nitriles on reduction. Nitriles on reduction to corresponding imines. Corresponding imine. I will tell you what is imine. Corresponding imine with stannous chloride. With stannous chloride in the presence of HCl followed by hydrolysis. Followed by hydrolysis gives aldehydes. Gives aldehydes. See, a two-step reaction. This is not a single-step reaction. It's a two-step reaction. The first one is reduction of nitrile to imine. What is this imine? We will learn. After that, we have to hydrolyze this. Now, any nitrile or any cyanide, we can represent. The general formula of cyanide is C triple bond N. The formula of cyanide is what? Cn. So nitriles or cyanides are generally represented as RC triple bond N. Here it can be R can be hydrogen, alkyl, aryl, anything. If it is hydrogen, it will be called as hydrogen cyanide. Now this on reduction. Now reduction The strong reducing agent, reduction is addition of hydrogen. Remember, the opposite of oxidation is called as reduction. The removal of hydrogen is called as oxidation. Addition of hydrogen will be called as reduction. So on reduction with stannous chloride, tin chloride in HCl, this is a strong reducing agent. Stannous chloride will react with hydrochloric acid to give you hydrogen. Now what happens is one hydrogen attacks this carbon, the other hydrogen attacks this carbon. Therefore, we get RCH. One pi bond will break. You will have a double bond and NH. This is called as imines. So NH group is called as imines. NH2 group is called as amines. NH group is called as imines. So cyanides or nitriles on reduction with stannous chloride and concentrated HCl, reduction takes place forming an imine. This imine on hydrolysis, we can write it as H2, hydrolysis. This also happens in the presence of hydrogen. So what happens is, now I can show like this. NH and H2 gets eliminated as ammonia. The byproduct is ammonia. So in place of NH, what goes? Oxygen goes. Therefore, we have R, CH, and double bond O. This is nothing but aldehyde. It's nothing but aldehyde. This reaction is called as Stephen's reaction. This reaction is called as Stephen's reaction. So reduction of nitriles to imines, and these imines are hydrolyzed to form aldehyde. This reaction is called as Stephen's reaction. Followed?
Yes, sir.
Yes. Now, one more method of preparation, and then we'll stop and continue with the other set of preparation in the next class, possibly. All right. So the next method of preparation is called as Itard's reaction or Tard's reaction. This is regularly asked question. In your boards, they regularly ask this reaction, Tard's reaction. They can ask you what is Itard's reaction, or they can ask you what's the oxidizing agent in Tard's reaction. So this is from toluene. Toluene. Now, when toluene is heated with chromyl chloride, when toluene is heated with chromyl chloride, what is the molecular formula of chromyl chloride? They will ask. The molecular formula of chromyl chloride is CrO2Cl2 in carbon tetrachloride. Followed by hydrolysis. Gives benzaldehyde. It's an important reaction. Gives benzaldehyde. We will not show this reaction in two steps because this reaction is very complex. The mechanism of the reaction is very complex, and we do not expect the mechanism. Now, toluene we can represent like this. Toluene is C6H5CH3. This is toluene. This toluene, when you heat it with chromyl chloride and carbon tetrachloride, CrO2Cl2 in carbon tetrachloride, on heating, it gives nascent oxygen. So, to simplify this, I will write the CH3 like this. CH and H2, I will write. CH3, I'll write like this. So what happens? Two oxygen atom we have. One oxygen reacts with this two hydrogen to get eliminated as water. In place of this two hydrogen, this oxygen goes. So the product formed is C6H5CH4. This is called as benzaldehyde. It's called as benzaldehyde. This reaction is called as Tard's reaction or Itard's reaction. Whichever way it's comfortable for us to pronounce, you can. All right. So what is Itard's reaction? When toluene is heated with chromyl chloride, what is the formula of chromyl chloride? They'll ask. Molecular formula CrO2Cl2 in carbon tetrachloride, followed by hydrolysis. It gives benzaldehyde. All right. Followed with this reaction. So many reactions we learned today.
Yes, sir.
Yeah, a lot of reactions we have learned, a lot of information given. So all this you should remember. We'll continue. Still, we have few more methods of preparation. We have from esters, we have Gattermann's reaction, we have Gattermann-Koch reaction. From acid chlorides, we have, all right, again from nitriles and benzene. We have so many methods of preparation we have in our syllabus, and then we will learn with the chemical properties of aldehydes and ketones together. All right. So I will stop the class. Ma'am, sir.
Yes, sir. Thank you, sir. Thank you.
Yeah,
Thank you, sir.
Thank you.